Hello, everyone, wherever you are on the world. My name is Thomas Steiner, and I work for Google as a developer advocate focused on Chrome/the web in general. Today, I want to talk about learning from mini apps. You can see the slides links if you, slides link if you want to follow at home.
May I suggest that you go a little bit slower?
Oh, okay.
Thank you.
You can see the slides link, go.gle/learning-from-mini-apps if you want to follow along at home. And there's also a link for the IRC chat if you want to chat. All right, with that, let's get started with a couple of caveats. So first of all, the mini apps ecosystem is mostly, but not exclusively Chinese, and I don't speak Chinese, and I've never lived in China. So whatever I tell you, I've learned by scanning one screen with another screen and using Google Translate. So if there's anything wrong, don't believe me. Check for yourself with a Chinese speaker. But that being said, I believe I fairly accurately understood what's going on. And there's a lot of content, so I'm going fast. But yeah, you have the slides link, so you can follow along at home. So before we can start talking about mini apps, we need to talk about super apps. Super apps are apps that are hosts to other apps that run within the super app, the so-called mini apps. Some popular super apps are Tencent's Wechat, the app of the search engine Baidu, Ant Groups, which is an affiliate of the Chinese Alibaba group, Alipay, and then also ByteDance's Douyin, which some of you in the US and in the world might also know as TikTok, with some interesting political developments happening right now around the company. And the first three companies are also known as BAT, Baidu, Alibaba, Tencent. So if you come across this acronym, that's what it stands for. Installing a super app is possible on several platforms. They're all available on iOS and Android, and sometimes on Windows and macOS. Be aware that the versions that you can find on mostly also the Western official app stores may not always have all the features of the Chinese version. So sometimes if you want to get the full experience, you might need to sideload from untrusted sources. Obviously, proceed at your own risk. If you have the slides, these are all the links for the Wechat, Baidu, Alipay, and Douyin super app. As I said, there's some regional restrictions. For example, Douyin can only be downloaded on the iOS App Store in China, but not anywhere else in the world. All right, many apps. So finally, we can talk about them. They're small apps, commonly less than 4 megabytes, and they require a super app to run. What all the mini apps have in common, independent of the super app that they run in, is that they're built with, well, dialects of the web technologies, HTML, CSS, and JavaScript. The runtime of mini apps is a web view within the super app and not the underlying operating system, which means that mini apps are cross-platform. So the same mini app can run in the same super app, no matter if the super app runs on Android, iOS, or another operating system. How do people discover mini apps? A very common way is through branded 2D barcodes. You can see one on the right-hand side. If you use Wechat, you can scan this, and then you will land right on the demo application that you can see on the screenshot. And having this kind of branded barcodes solves a very important offline to online challenge. So for example, if you have a physical e-scooter, barcode on the scooter can bring you to the rental mini app so that you can actually rent the scooter on the street. Mini app discovery can also happen through regular in-app search. So you have a super app, and then within the super app, you can just search for an app. A lot of the super apps are also somewhat chat messages, chat applications. So Wechat, as the name suggests. So super apps, mini apps can be part of chat messages, or they can also be part of a news item in a news feed. And a couple of mini apps also have the concept of verified accounts. So an official brand account, for example, that can have mini apps contained in their profiles. And many apps can also be highlighted when they are physically or virtually geographically close. So for example, on the right-hand side, you can see Wechat. And in Wechat, it has a mini programs nearby search. So your location can bring up, I don't know, a mini app of a store that you're standing in front of. The mini app experience, once you scan such a QR code or once you just launch a mini app from wherever, is pretty consistent across all the super app vendors. You always have a themable top bar with the mini app's name. And then on the right-hand side in the top corner, you typically have a close button and an action menu button. And this action menu brings up features like sharing, like favorites, or allowing you to add the application to the home screen. But you can also report abusive apps there or provide feedback on the app and also change some settings. For example, what kind of permissions an application gets. UI paradigms of mini apps. Well, usually you have a bottom tab bar, which is pretty frequent also with just native applications for navigating in between the different main sections of the app. And then you have views where you can descend in the app's hierarchy. A lot of super app providers offer components that help you to develop common UI paradigms very quickly, like for example, carousels, accordions, progress bars, spinners, switches, maps, etc. On the screenshot on the right, you can see a demo of a carousel or swiper component with a couple of options. So you can, for example, present or not the dots or make the carousel auto advancing. And by having all these high-level components directly built into the super app, many apps are generally very consistent, which is also what is encouraged by Wechat's mini app design guidelines, just like with Apple design guidelines, that you have a common way of doing things. For serving, where do mini apps get served from? That's very interesting. As a separate set of resources, mini apps are served as an encrypted packaged app. That is all the archives that contain all the core resources in just one file. And they're also served from the super app provider directly and not the host origin, but they can of course still access APIs from the mini app developer if the developer chooses to. But in order to do so, many apps have to declare the list of origins that they want to request. So there's no just random asking for whatever example.com within the app. Many apps need to declare beforehand that they want to access example.com before they can do that. Caching updates and deep linking. Many apps are kept in the cache of the super app. So for the next time they load, this happens almost instantly. On the right-hand side in the screenshot, you can see the W3C APKG files of Wechat. You can sort of see directly how they look like. The size here is 1.1 megabytes for this particular example, so it's small-ish. Many apps have version numbers, and these version numbers are part of the launch URL. So a super app knows directly when it's trying to start a mini app, if the version is still the current one that is cached, or if a new one needs to be loaded. And launch URLs also have pages that you can use for deep linking, so you can link or deep link into specific subsections of an application. Mini apps also have sitemaps where they can declare which of the pages and which of the sections of the mini app should be crawlable by the super app crawler, so that you can search for content within these mini apps. For security and permissions, many apps are reviewed by the super app providers before people can use them. So people in general perceive them as more secure than random web apps that obviously everyone can just create. And many apps need to declare all the permissions that they use in a manifest. And sometimes some mini apps also provide a way to say why a certain permission is needed. So as a developer, you can provide an explanation that sometimes also then gets shown to the user when the mini app requests a certain permission and shows a prompt, plus, as I just said, sometimes an explanation. Many apps have access to very powerful features, and this happens through a so-called JavaScript Bridge that gets injected into the web view where the mini app runs in the super app. And this JavaScript Bridge acts as the connection to the host operating system. So as an example, if you have a mini app that has a JavaScript function, for example, get connected Wi-Fi, you can then use, well, this under the hood then uses Android's get connected info or get connection info API or iOS CN copy current network info APIs. But for the user, for the mini app developer, get connected Wi-Fi is the function that they need to call. It's fully implemented in JavaScript, so there's no Objective-C, no Java, no anything, no Kotlin. It's just JavaScript. Talking of these powerful features, there's a long list of features that many apps have access to. There's Bluetooth, NFC, iBeacon, GPS, the system clipboard, orientation sensors, battery information, calendar access, phone book access, screen brightness control, which is what you can see on the screenshot on the right-hand side. So a mini app can control the screen brightness of the device, file system access, vibration hardware, camera and microphone access, screen recording access and screenshot creation access, network status, UDP sockets, so raw sockets, barcode scanning, device memory information, and some more. So really super powerful features that are exposed to mini apps. One very powerful feature of mini apps is also identity payment and the social graph that is built into most super apps already. So a lot of super apps already have your payment information. And for some super apps, you even have a government verified identity. So someone needed to go somewhere to some sort of official institution, show their passport or something, and then their whatever WeChat account would be verified. So there's a strong identity that is connected with the super app, and obviously also payment data, because some of the super apps are from payment providers like Alipay, which, as the name suggests, is served for payments. You have apps like WeChat that have a social graph of your chat connections. And one mini app that I found interesting to look at was the Walmart mini app. And this is on the first view, so it didn't really log in or anything. The Me subsection on this Walmart mini app just greets me with a very familiar face. So this is me, and I felt right at home in the mini app of Walmart, despite not speaking any single word of Chinese. It felt like, oh, wow, this is me. And I have a section already on Walmart. I probably want to shop there. Up next is a big topic of developer experience. Mini apps are not developed just like regular web applications in, I don't know, Visual Studio Code or something. But for mini apps, you download an IDE that is provided by the mini app or by the super app provider, actually. Again, if you have the slides downloaded, the underlined words are links. So you can have the Wechat Devtools, Alipay Devtools, Baidu Devtools, or ByteDance Devtools and download them to your computer. They're typically available for macOS or for Windows. Obviously, everything is in Chinese, or almost everything is in Chinese. So if you have an app like Google Translate that can scan your screen, this is very helpful for getting around. And for getting started, a lot of the, or actually all of them, offer Hello World projects. Again, the underlined words are links, so you can get started very quickly and just have a baseline experience of an app running. Right. For the development flow, when you launch the IDE, typically you need to log in. This happens with a QR code that you need to scan with the super app where you already logged in. And once you're logged in, the IDE then knows who you are and lets you start programming, debugging, testing, and obviously also in the later stages, submitting your app for review to one of the mini app stores. Here's just a couple of screenshots. So this is Wechat Devtools. I just quickly walk you through. On the left-hand side, you have the emulator, then you have the code view. At the bottom, you have the DevTools. Alipay Devtools is almost the same, just a little differently arranged. On the right-hand side, you have the emulator. Then on the left-hand side, you have the code. And at the bottom, you have the DevTools. Ryder Dev Tools is, again, the same like Wechat Devtools. On the left, you have the emulator, then the code, and at the bottom, the DevTools. And then ByteDance, so remember this is Douyin, TikTok. On the left-hand side, you have the emulator. On the right-hand side, the code. And then at the bottom, you have the DevTools. So it's kind of weird, but there's DevTools within the DevTools. I come to that in a couple of minutes. The architecture of all these DevTools is fundamentally the same. You've seen it. They're, as far as I could reverse engineer, all based on the Monaco editor, which is also the editor that powers VS Code internally. And in all the IDEs, there's a debugger built in, which is based on the Chrome DevTools frontend with some modifications. I'll talk about those in a couple of minutes as well. And the IDEs per se are implemented either as NW.js or as Electron apps. And the simulators or emulators in these IDEs are then implemented as web views for either Electron or NW.js. Testing on a real device is super easy. You just press a button, and this button then shows a QR code. You scan this QR code with your real device, and immediately you can start testing the application that you're developing that is just delivered over the cloud. So super fast, super easy development flow, real device, cable-less development. You can also remote debug. The flow is almost the same. You just press a different button. This shows a different barcode. And then you can directly with your big laptop or big computer screen debug or remote debug the small application running on your device. So you can see here, I've highlighted something, whatever, a label or a select box here, and I can inspect it with my big laptop. For the DevTools customizations, there's a couple of things that the IDEs change. So for example, the Elements panel in Chrome DevTools, as you see it in the browser, has been replaced with something called WXML. And if you use this to debug, so it behaves almost the same like the Elements panel. If you use this to debug one of the elements on this page here, you can see that I'm actually inspecting an image element. So if you look close, it's pretty small, but maybe you can still see it. It's an image element with a bind tab attribute, with a class attribute, with a mode attribute, with the source, with a role, and so on. So yeah, it's like the Elements panel, but you can see it's tailored to the programming world of WXML, which is what's used by Wechat. Because all these IDEs are built with web technologies, so as I said, Electron or NW.js, you can inspect them with Chrome DevTools. So essentially just inspect DevTools with DevTools. And if you do that, you can see how internally things are implemented. So for example, if I inspect with DevTools, you can see that image that I just talked about under the hood actually is implemented as a regular custom element, so HTML custom element. So you can see there's an inner div that has the style of a background image with a source and so on. The custom element is called WX-image. It has a class, So it's just a regular custom element that they disguise to the developer as an image element if the developer only uses the Wechat DevTools and doesn't inspect the DevTools with DevTools, which is what I've done here to reverse engineer how things work. For CSS, many apps extend CSS with so-called responsive pixels. I'll talk about those a little later. And it's the same with the styles panel. So it's almost the same like in Chrome DevTools, like in the web version of Chrome DevTools. but with some customization. So here you can see I'm inspecting a padding of 200 RPX responsive pixels, and it just behaves as I would expect. In the emulator, I can then, of course, switch the device. I can simulate a different device, like different iPhone. Pixels would just work as expected. Performance auditing is also possible in DevTools. So in Wechat Devtools, they have Lighthouse-inspired performance audits. If you look at the categories here, they are total, performance, experience, and best practice. And you can see I have 100 everywhere. So that's pretty good, I guess. The UI will be very familiar if you've ever worked with the Chrome DevTools Lighthouse. It's obviously very inspired by the Lighthouse project. Something that I found very helpful in just getting up quickly is API mocking. So they extended Chrome DevTools by adding a mocking section. So you can have remote calls that you just mock locally. So you don't have the server, you don't have to build the server. You can just work with the mocked API values locally. Pretty cool. All right. So for the markup, how do you build and write mini apps? So rather than with plain HTML, you use dialects of HTML, as I've called it. It's not technically a dialect, but it helped me understand most of the concepts better by just thinking of them as a dialect. If you've ever dealt with Vue.js, the text interpolation directives of Vue specifically, you will feel immediately at home. But thinking a little bit back in the good old world of XML, a lot of the concepts have existed a long time before, for example, with XSLT. I have to say the following code samples are all from Wechat's WXML, but the concept is the same for all the mini apps platforms. So for Alipay, the thing is called AXML. For Baidu, it's called Swan Element. For ByteDance, it's TTML, and so on. And the underlying programming model is the model view model controller idea. So it's a similar to Vue.js concept of programming. So let me show you some examples to make it clearer. For data binding, you have a WXML message, a view, then the curly braces double notation message, and then in the JavaScript, you have a page that has a data object that has a message property with a value of hello world. So if this gets rendered, the message is replaced with hello world. So pretty intuitive, pretty straightforward. You have probably seen this before in similar ways with master hash templates or anything. And as I said, with the Vue's text directives, it's almost the same. For lists rendering, you have the WX4 directive that you pass an array of things. And then you can see here, the data for this is an array with just the numbers. And they then get just directly pasted into, or not pasted, filled into the view. So it loops over all of the array entries. So pretty straightforward, very easy to create lists like that. Conditional rendering happens with WXIF and WXElif. So you can see here, my page data is view of a value of 2. So in this case, it would render either if view was 1, it would render 1. If view was 2, which is the case, it would render 2. So pretty straightforward, again, for conditional rendering here. For templates, you have a template that has a name of person, then you have a view, first name, and then you can see curly braces again, first name and last name. And to instantiate this, you can then say my template is a person, and the data for this person comes from a field called person A. And then everything will be just magically filled in. So pretty straightforward again. You can probably immediately understand what is going on just by looking at these two code snippets. To the next topic, styling. Styling happens with dialects of CSS. So again, it's not technically a dialect, but it helped me understand what's going on. Just like before, they don't call it CSS, they call it WXSS. For Alipay, they call it ACSS. Baidu calls it CSS. ByteDance, they call it TTSS. What they all have in common is that they extend CSS with responsive pixels. So essentially, if you have ever done Android development, that's something that's familiar to you under the name of density-independent pixels. So that's essentially the core addition to CSS that they make. You work with it just like with regular pixels. So you can see here, I set a padding of whatever container to 200 RPX that then get translated to the device dependent pixels by the engine. So for the developer, there's nothing to do. You just say it should feel like 200 pixels, and then the engine does its magic. For styling, you can also use just like inline CSS. So you can see here a view style equals to color and then the curly braces again. So you can have text interpolation, work with that. And for the components, and I talk about components a little later, they don't use shadow DOM. So they do not use shadow DOM, which means all the styles that you declare on a page will reach into all the components. This is not a problem because pages, I will talk about pages a little later. And common style sheet file organization is to have one root style sheet where you have shared global styles that get applied to everything, and then individual per page style sheets that are specific to each page of the mini app. Next topic is scripting. They don't call it JavaScript. Again, it's a dialect. They call it a safe subset of JavaScript, including modules that use varying syntaxes that reminded me of CommonJS or Require.js. They don't have dynamic code execution, so you don't have eval and you don't have new function. So you can't shoot yourself in the foot easily. With regular JavaScript, this would be allowed, which is why they call it a safe subset of JavaScript. The scripting execution context is V8 or JavaScript core, depending on the device. For Android, it's V8. For JavaScript core, this means it's running on an iOS device. And in the simulators, it's V8 or NWJS. And coding with ES6 or newer JavaScript syntax is possible because the DevTools automatically transpile the code to ES5 if the build target is an operating system with an older web view. But this is, of course, becoming less and less relevant just because web browsers in general and web views catch up. And then the build dynamically transpiles to older syntax only if necessary. So for Wechat, they call their scripting language WXS. So you can see a pattern here. Alipay calls it SJS. ByteDance calls it SJS2. Baidu just call it JS. So that's essentially it. For including a tag, for including a script, you need to include a special tag, WXS in Wechat's case. So you can see here, I have a script that's embedded in WXS, message hello world, module exports message equals to message. And then I can just, in my view, make use of the value or of the exposed or exported value here by referencing the module ID m1.message. Modules can also be loaded via a regular source attribute or imported within one module from another. So you can see here WXS pointing to a source, giving it a module name of tools. And then in my view, I can use it as tools.message or just call a function, whatever. Or I can just inside a WXS file require another one. So pretty straightforward if you've ever done Node development or just any kind of JavaScript development with Require.js, this immediately feels familiar to you. JavaScript Bridging API is what enables the mini app to hook into the native operating system. And this is, of course, what makes all the powerful features that I talked about, like Bluetooth and web USB and whatever possible with these native capabilities. But of course, not all devices have all the features. But luckily, all the platforms have a pretty straightforwardly named function called can I use, where I can just ask via a function call, can I use whatever I want to use? So for example, for ByteDance, it's called TT can I use? And you can test for any kind of thing. So for example, you can test, does the current device support the swiper component? If you remember a couple of slides back, I had the swiper component, the carousel. You can just ask tt.can I use swiper? And then the response will be yes or no. You can also test if a particular field is supported. So it's not limited to components. It's also open to any kind of, I don't know, lower level fields that may be present in only certain things. So feature detection is super easy just because everything is possible through can I use. Components. I talked about components a little earlier. If you remember the Wechat image web component that under the hood was implemented as wx-image. But then technically not all of these components are web components. So for example, map and video that get exposed as components on a mini app are not rendered as a regular HTML5 video or as a regular map, as a Google Map component or something, but they're rendered and then layered on top of the web view as operating system native components for performance reasons. So you have a web view, and then on top of the web view, you can have a map, for example, or a video that's using native code. For you as a developer, this doesn't play a role at all. It's not exposed to you. You just program them like any other component. And I show this in a couple of seconds. Just for you to get a feeling for what kind of components are available. You have I think this is from Alipay, you have view containers, you have basic content, you have form components, and just randomly looking at things. And you have checkboxes, you have switches, you have text areas, you have progress, you have rich text, you have scroll views, you have cover image, movable view, and so on. So there's a lot of components that are already available. I just showed map and video, audio, and so on. So there's a lot of things available. So this list is by no means complete. I just had to stop somewhere because the slide would have been too full. So let me show you how you can use such a component. On the left-hand side, you can see now AXML. So this is using Alipay syntax. You have just a nested view. You can see here you have an A4 directive. So this is Alipay's listing view. And then we just create for each of our items in an array a page section demo. And then we create an image object. It has a couple of attributes, class, mode, on tap, on error, on load, source, lazy load, default source, and so on. And then on the right-hand side, you can see how I can hook up all these functions to the to the JavaScript functions. Just a second, please. So you have the page object, and then within the page object, you have data with an array of the various items that you want to loop over in your array here. And then you have the couple of functions like on tap, image load, and so on. So you can see what's happening at each stage. So pretty straightforward. You have a mapping to the functions that get called if something in the image happens, like an error, a load event, or you can select the behavior. Lazy loading should be true or false. You can have a default source, which is the placeholder while the image is loading, and so on. So a lot of the things that we as JavaScript developers would need to implement with intersection observer, for example, for lazy loading. I know lazy loading has loaded as an attribute now, so it's a little easier nowadays than it used to be a couple of months ago. But nevertheless, a couple of things like placeholders or loading indicators, this is all possible just declaratively using this sort of syntax. When you look at the documentation, so you can see here, this is Alipay's documentation of the image component. You can see that there's an embedded mini simulator running right into the documentation that it can also pop out. So you have an editable test playground here. So you can play directly with the implementation in the browser and see what's happening in the simulator that is just embedded in the browser, in the documentation, for seeing the effect of your changes. And for each component, there's also a QR code that you can just scan that brings you right into the Alipay application, so you can test on a real device. You can see here, this is an Alipay sample mini app that just shows the components. So for each of the components, they make such a testing app available. And you can also connect directly to Alipay Devtools. They let -tiny. So the documentation, Alipay Devtools would open, and you're brought right into a minimal example that you can edit right in Alipay Devtools. So as a developer, it's super easy to just directly get started, play with the element in the documentation, hook it up to your local device for testing, or just edit away straight in Alipay Devtools. Super fascinating, very easy for developers to get started. If you happen to have a need for a custom component, so something that is not covered by the very long list of all the shipped built-in components, you can do so. It's not using custom elements like in HTML custom elements syntax, but something proprietary. So you can see here, it has properties, it has data, it has methods, it has lifetime events. So essentially, it's the same-ish like web components in the web world, but a little simpler. So you have attached, you have detached, created, and ready as the lifecycle functions. And then you have also page lifecycle events that you can react to, like show or hide. The mini app lifecycle is pretty similar as well. Each mini app has a lifecycle that needs to be the mini app needs to be registered with a global object called app. And then in this app object, you can connect some functionality to the lifecycle functions, launch, show, hide, or error. And then you can also set global data that is shared across the application. And like that, you sort of just make sure what's happening if your mini app gets shown, gets hidden. Remember, this is all a multitasking. So you can have a mini app running and then you multitask away from it, and then task back to it, which would mean the hide event would be called, then the show event would be called, and then maybe at the beginning you have the on launch event that sets up some state or something. So pretty straightforward. Each mini app consists of a couple of pages, and just like the app per se, all the pages as well have lifecycle events that you can connect to and listen to. The core events are load, show, ready, hide, and unload. So when a page gets hidden, obviously the hide function gets called and so on. Some platforms also offer some more conveniency functions, like for example, pull down refresh, that allows you to react on like pull down to refresh directly with a built-in function that is just a lifecycle function of the page, so you don't have to build it yourself. The build process. So everything is abstracted away from you. You don't ever touch the build process at all. So if you've ever set up something like Rollup or Webpack, forget about it. This is just be done automatically by the IDE. And under the hood, it's just using industry tools like Babel or PostCSS for CSS transforming. If you've ever used something like Next.js or Create React App, it's pretty similar. And likewise, if with a Next.js app or Create React App, you decide to never touch the build process, you don't have to in many cases. But here for the mini apps, you actually never ever do this. It's just not a concept. The IDE just doesn't expose this at all. If you want to submit a mini app to a mini app store for inclusion in whatever the Wechat or Alipay app stores, you need to submit for review. And in order to do so, in the IDE, the build process completely automatically deals with signing, encrypting, packaging, and then finally uploading to the super app provider. You don't have to touch anything at all about this. If you've ever done Xcode submitting for review in the Apple Store, it's a lot more elegant than that. So it's just one essentially button, and everything just flows from there. They made it super convenient and super easy. So why do I tell you all this? Why did I dive into this? I wanted to learn something from many apps, especially with the view of a web developer. And the learnings I've taken so far are build something what I call multi-page, single-page apps. So I'm coining that term now, MPSPA, multi-page, single-page app. Why? Because each page is its own world with very little shared state. Like that, you get scoped CSS for free, you get navigation and routing for free, you get route-based code splitting for free, you get just so many things for free that in modern single-page applications, you have to, or the framework has to rebuild for the browser. If you use something, as I said, I'm coining that term, a multi-page, single-page app, you get a lot of this for free. I will show you what I mean by this in a couple of minutes. Use custom elements or just lightweight framework elements in the sense of, I don't know, Preact components, because they make your life a lot easier. If you don't have to hook up, I don't know, very complex functionality, if you can just use an accordion component, if you can just use a swiper component, it makes your life so much easier. Custom elements exist today. There's a lot of frameworks and a lot of different custom element libraries out there that you can use that make your life a lot easier. So use them. And the web is an application platform, arguably. And look for the growing list of powerful capabilities that the web already offers today. Personally, I work on a project with a lot of other folks that's called Fugu. You can see here the blowfish, Fugu blowfish. So in that context, we make a lot of these powerful capabilities that you needed a JavaScript bridge for in the mini apps world, just for regular web developers. So have an open eye and look for those powerful capabilities and how you can use them in the browser today. So to make this a little more concrete, I tried to build a sample app. I'm not sure if any one of you is aware with the concept of HIT training, high intensity interval training. The core idea with HIT training is always you have a period of active time and you have a period of resting time. So you can see here, this trainer is doing, I'm thinking something like sit-ups or I don't know, whatever, some activity. So I can see he's 28 minutes or seconds, sorry, 28 seconds to go. And then he rests for 10 seconds. And this is just essentially two progress rings that alternate. So it's always activity time, resting time, activity time, resting time, and so on. So I thought, why not building something like that? And that's what I did. I built an application called HIT Time. It has a navigation bar at the top. It has a main view in the middle, and it has a tab bar at the bottom with the different subsections. So workouts, timers, and preferences at the bottom, where you can choose what you want. The navigation bar at the top always shows you where you are. So you can see, I'm in the workout tab right now. And then in the main view, you can see here the three progress rings, active time, resting time, and then the number of sets that I need to do for each of those. And obviously the start, pause, and reset button. It's a responsive application. So you can see here responsive layout. If I twist my phone to a landscape orientation, you can see the progress rings get laid out horizontally. It has a dark and a light mode. And it also has custom themes. So you could see on the previous slide, the main theme was blue. Here, the main theme is green. And then you have in-app views. So if you want to set a new timer, the application just shows me an in-app view that allows me to do just this one thing. And then I can go back, I don't know, add a new timer or just cancel. And you can see at the top, you have this back arrow that you know from Android and from iOS applications. But because this is just a view, obviously just your regular back button, so your physical hardware back button that you may have on your Android device, or a back swipe gesture just works. There's nothing you need to do, it's just there. So looking at the application architecture, it's essentially just a couple of iframes. This is all the architecture. It's not complex at all. On the top, you have the navbar. You can see here the URL is navbar/navbar HTML. Then you have a div with ID pages. Inside there, you have the 3 iframes for workout, timers, and preferences. And then at the bottom, you have a 4th iframe that is set to the source about blank. So nothing, essentially, that has the ID of new page. And this blank iframe is used whenever I need a custom view. So when I have this timer setting, this is what the about blank then dynamically gets set to. So once you navigate away from this, it just navigates back to about blank. And like that, you have a very simple, very performant architecture. And then finally, you have the tab bar at the very bottom, and that's about it. So for the markup, how does this work from a markup point of view? On the web, we have something called lit HTML, developed by a colleague of mine in Google. If you remember what I showed you earlier for the WXML, or also for the Alipay syntax, it's pretty straightforward. So if you have a look at the section here of my application, the start button, the pause button, and the reset button, they're just literally there, button, add click, which hooks up to an event handler start, pause button, event handler pause, la 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 la. So nothing exciting here. You can see all the strings come from a global object strings for localization. So you can translate the app to different languages. That's all the markup you need for the pause buttons and start buttons and reset buttons. And then you have the progress ring, which is a custom element that I got from a library called Shoelace. So SL Shoelace progress ring. It has a class of sets, and then the percentage, which is essentially just my calculated number of sets that I need to do still. And you can see that's all the markup that there is. And then inside of the custom component here, there's a slot that I can use for my sets and my current iteration. So sets is 1 in the screenshot. And that's it. So this is all the markup that's needed for this. The router. The router is actually super, super simple. All I do is I listen for the back event, prevent the default, and then just navigate the top window, because everything is running in iframes, 1 level back. So that's a router. If you press the little triangle here and go back, or if you just swipe back, this is what's getting called. That's routing. As I said, you get everything for free just because it's all built in the browser. It's just different iframes that get orchestrated accordingly. That's it. Nothing more to it. Styling. As I said before, every view is its own world. So you get scoped styling for free. So this is the style for my core preferences page here. So you can see I'm just using the element names directly. So no fancy BAM syntax or no fancy whatever class nomenclature that I need to adhere to. It's all just literally the HTML tags as they appear. There's no clashes at all because every view is its own world. So you can see it's just standard CSS, grid syntax, whatever, whatnot. Nothing super exciting. It's just simple, and that's what I wanted it to be. If you're interested in this, I've made a very, very early prototype available. It's on GitHub. You can play with it. It's not super elegant quite yet. You will probably find bugs, but I think the concept per se is pretty powerful, especially if you look at the architecture of the pages. You can see all the pages in the pages folder are its own world. So if you ever need to find out where is something happening, how is something realized in one particular view, you can just navigate to the page directory and have everything in one place. I have to say, this application doesn't bundle yet. So you can see it's just introducing or including lit HTML as, per se like that as a module. In a production app at some point, you probably want to add bundling. But for local development, this is completely working like that. The same goes for Shoelace. So these are the two third-party components or third-party libraries that I'm using here. Everything else is just built in. You can play with it. The link is on the slides here. So you have your device that you can test it on. It should be working on desktop and on mobile. There's some funny talking. So if you have a compatible device on Android, for example, it will tell you the resting time and the active time. So just give it a shot, play with it. And again, I want to repeat this so that it sticks. What can we learn from this? Build multi-page, single-page applications, MPSPAs. I think it's a super powerful concept. It works surprisingly well, just going back to the roots. Use custom elements or even just lightweight framework components, because declarative layout makes your life so much easier, especially if I just go back a couple of slides, especially if you look at the progress ring markup here, just your data logic somehow figures out what is the number of sets, so data.sets, and then the view just automatically updates. And lit HTML renders really just the changed things. So you don't need any kind of virtual DOM diffing or anything. It's just powered by lit HTML directly. And again, the web is an app platform. So look for the growing list of powerful capabilities that the web offers. You don't probably, in many cases, need access to, I don't know, super powerful features that are really just available behind JavaScript bridges. In a lot of cases, maybe the web is good already like that. And with that, thank you very much for listening. You have the slide links again. You have the IRC link if you want to chat. I have my contacts here, so you can ping me on Twitter, send me an email, or if you are in China, I'm also on WeChat. And thank you very much for listening. I'm happy to take questions now.